The overall goal of this procedure is to reproducibly characterize spatial light modulators by mapping their frequency response to angular output.
This method helps to provide vital data required to answering key questions in the electroholography field, such as identifying guided leaky mode transitions and optimization requirements.
The main advantage of this technique is that it clearly separates leaky mode transitions and allows us to quickly obtain repeatable information on their linearity, relative intensity, angular spread, and operational frequency.
A visual demonstration of this process is critical, as the alignment and the prism coupling both rely on visual cues that are hard to explain.
To characterize the device, first prepare to mount it on a radio frequency breakout board. Have ready a device, an RF breakout board, and 3 glass slides to make a mounting platform. One slide is larger than the other 2. It will form the base of the U-shaped platform. Begin to work with the largest slide. Place a generous bead of superglue over the leftmost quarter of a slide's longest dimension. Next, orient a smaller slide so that its longest dimension is perpendicular to that of the first slide. Align the left edges of the 2 slides so that their lower left corners overlap. Put them in contact and apply firm and equal pressure to the slides until the glue sets. Repeat the analogous steps for the right-hand side. This will result in a U-shaped structure. To mount the device, apply double-sided tape to the platform at the center of the U. Now, work with the leaky mode modulator to be characterized.